We shall go for one more lecture on advanced level problems on circular motion. This will be the sixth and last lecture for the time being in this series of lectures on circular motion, because I thought I must include two particular problems which I have been seeing for many years now. The problems are tough and long, but my feeling is that if you can understand and follow them, you should never have any dearth of confidence in attempting a problem of circular motion anymore. And as usual, we shall mark it with 3 dots to show the difficulty level of the problem. So let's see what we have done so far. Original figure given with the question, that was my figure A. Then I had drawn a second auxiliary figure to draw this geometry of the situation and found that the depth through which the ball is falling in coming from P to Q, that H was found by this first equation. Then applying mechanical energy conservation principle between P and Q, we got the speed acquired by the ball at position Q given by equation number 1. Writing equation of motion of the ball in radial direction, I got equation number 2. Combining 1 and 2, we got eventually the normal force exerted by the inner sphere A on the ball radially outwards is mg into 3 cos theta minus 2, while the other sphere, the outer sphere B, does not exert any normal force on the ball in the interval of theta lying between 0 and cos inverse 2 by 3, including those two values. So to remind you once again, the question is here. A brief glance into that, if you require it at all. I'm supposed to find out total normal force exerted by the sphere on the ball as function of theta. Therefore, let us see now what happens when the value of theta exceeds this critical value of cos inverse 2 by 3. Let me draw one more figure here. This was the original figure given. I'm going to show what is going to happen now if theta becomes large enough, right? So once again, for clear understanding, I am just drawing a vertical line to the center of the path. That's in dashed line. Of course, this is center O. This was the original position P at the top. The ball was released from this position, touching the inner sphere's outer face and leaving a gap with the outer sphere, right? This was the inner sphere A and this was the outer sphere B, say I'm saying. Then I had drawn, this was the condition at some small value of theta. This position I consider to be Q and the ball is here. At a value of theta which is small, I am writing it to be less than some critical value theta C. It will become clear in a short while. I show one more angle and then one more angle becoming later. So this was the angle I'm talking of as the critical angle, right? This angle. This angle, that is theta critical, was found to be cos inverse 2 upon 3, that is roughly about 48.2 degree. At this value of theta, this normal force given by sphere A becomes 0, that is vanishes. Now the meaning of normal force vanishing is that the ball loses contact with the inner sphere A and starts moving radially outwards until it hits the small gap, until it hits the inner surface of the outer sphere B and start moving down, remaining in contact with the outer sphere but losing contact with the inner sphere. That happens only when the value of theta is exceeding this critical value of theta C cos inverse 2 upon 3. So let me consider a situation where the value of theta, this I am showing, this whole angle. Let me go back to the blue ink once again. I'm talking of this angle, right? This angle theta, which is greater than the critical value, right? And I position the ball as well in the gap. This time, look at the figure carefully. This time the ball is touching the inner surface of the outer sphere B and not touching the outer surface of the inner sphere A.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.